Welcome. Today we are discussing Module 5.1, Data Chunking Strategies, Theory. Here is a quick look at where we are in our curriculum. Hello everyone. I am your lead curriculum director, and today we are diving into the absolute core of high-performance retrieval augmented generation, data chunking. Many developers build RAG pipelines only to realize their LLM returns irrelevant answers or hallucinates wildly. The culprit is almost always poorly chunked data. When we feed a massive document into a vector database, we cannot just throw the whole file in. LLM context windows are limited, and processing irrelevant tokens is extremely expensive. If your chunks are too large, you drown the model in noise. If they are too small, you lose critical context. Today, I will explain how to strategically balance this trade-off using architectural principles. I highly encourage you to check the link in the description to download the architecture diagram and script to follow along as we break down these strategies. Let's talk about the simplest form of partitioning, fixed-size chunking. Here, you define a set number of characters or tokens, say 500 characters, and slice your text every 500 units, occasionally adding an overlap of perhaps 50 characters to minimize data loss. Think of it like a blind paper cutter that slices down a page at exact intervals. If a critical piece of information, like an API call syntax or a financial metric, is split directly down the middle, the embedding vector becomes corrupted. Half the context goes to chunk A, and the other half goes to chunk B. Neither vector will represent the semantic reality of that sentence correctly. While it's easy to set up, using this blindly in production is a recipe for broken retrievals. Let us look at how we can do better. To solve the problems of fixed chunking, we use recursive character splitters. Instead of chopping text blindly, this strategy looks at logical structure. It tries to split by paragraphs first using double newlines. If a paragraph is still too large, it attempts to split by sentences using single newlines, then spaces, and finally individual characters as a last resort. This guarantees that paragraphs and complete sentences are kept together as much as possible. This approach is highly effective for technical documentation, academic papers, and general markdown. I have written a production-grade Python script to show how you can implement this with customized separator lists. Please make sure to check the link in the description to download the architecture diagram and script so you can use it in your own code. Now, let us examine the realistic terminal output when we execute this recursive logic on our technical text. Watch how the boundaries are handled on your screen. The algorithm evaluates the text and detects double newlines as the clean breakpoint. Because recursive splitters are powerful, is followed by a double newline, it isolates that sentence as a pristine chunk. Then it moves to the next block. It does not blindly cut off at exactly 120 characters. Instead, it looks for the closest space or newline delimiter that keeps the sentence structure intact. This output clearly shows that our text preserves its semantic meaning without spilling broken segments into arbitrary spaces. If you want to build truly state-of-the-art RAG pipelines, you must consider semantic chunking. Instead of using characters or punctuation, this strategy uses the power of your embedding model to decide where chunks start and end. Here is how it works. First, we break the document into individual sentences. Next, we generate embeddings for every sentence and calculate the cosine similarity between consecutive sentences. If sentence A is highly similar to sentence B, they belong in the same chunk. But when similarity drops significantly, say between sentence C and sentence D, our system automatically draws a boundary because a new topic has started. This ensures that every chunk contains exactly one complete topic, no more, no less. This is incredibly useful for parsing complex contracts, research papers, and chat history where subjects change dynamically. Now let us touch on the absolute cutting edge, agentic chunking. In this approach, we do not rely on fixed character limits or embedding similarity thresholds. Instead, we use a prompt-driven LLM as a highly intelligent editor. The LLM reads the document line by line. For each new sentence, the model is asked, does this sentence continue the concept discussed above, or is it a transition to a new topic? While this method is computationally heavier and more expensive, it generates contextually perfect chunks that align perfectly with how humans organize documents. If you are handling mission-critical, high-value data where retrieval errors could cost millions, this agentic approach is the gold standard of modern enterprise AI. As a principal engineer, your job is to look at this decision matrix. If you have flat, unformatted TXT files, recursive splitters are excellent. For deeply structured PDFs or technical documents, Markdown/recursive strategies are ideal. For complex documents with mixed topics, semantic chunking is highly recommended. That brings us to the end of our theoretical foundation. In the next upcoming lecture, Module 5.2, Writing a Document Loader and Splitter, Practical, I will guide you step by step through writing complete, production-ready Python code to load complex PDFs and split them dynamically using recursive methods. I will see you in the next class. Make sure to subscribe and check the link in the description to download the architecture diagram and script from today's session.